Before we begin, if you're fascinated by space, real astronomy, and the science shaping humanity's future, make sure to subscribe to the channel and turn on notifications. Every week, we break down the universe using real data, real discoveries, and real science. No speculation, no hype, just the cosmos as it truly is. Now, let's begin. When we look up at the night sky, every star we see, every single one, is unimaginably far away. Except for one system. Just 4.37 light-years from Earth lies Alpha Centauri, the closest star system to our solar system. In astronomical terms, this is next door. Alpha Centauri is not one star, but three, bound together by gravity. It is the most studied stellar system beyond our own, and for good reason. It may contain rocky planets. It may contain liquid water. And one of its stars hosts the closest known, potentially habitable exoplanet ever discovered. Alpha Centauri is not just another point of light. It is a scientific frontier and possibly humanity's first destination beyond the Sun. Alpha Centauri is located in the constellation Centaurus, visible primarily from the southern hemisphere. From places like Australia, South America, and southern Africa, it appears as one of the brightest star-like objects in the sky. Despite appearing as a single star to the naked eye, telescopes reveal its true nature. The system consists of Alpha Centauri A, Alpha Centauri B. If Alpha Centauri A replaced our Sun, Earth's climate would be only slightly warmer. This similarity makes Alpha Centauri one of the best candidates for hosting Earth-like planets. Its stable energy output and long lifespan provide the exact conditions scientists associate with long-term habitability. For decades, astronomers have searched this star for planets, but detecting them is extremely difficult due to the brightness of the star and the interference from its binary companion. Alpha Centauri B is slightly smaller and cooler than the Sun. It is classified as a K-type star, often called an orange dwarf. Key characteristics: about 90% the mass of the Sun, emits less energy, longer lifespan than Sun-like stars. K-type stars are particularly interesting for astrobiology. They are more stable than red dwarfs and live longer than G-type stars, providing billions of years for life to potentially develop. Alpha Centauri A and B orbit a common center of mass, sometimes moving closer than the distance between the Sun and Saturn. Despite this dynamic environment, computer simulations show that stable planetary orbits are possible around both stars. Proxima Centauri is the smallest and faintest star in the system, but scientifically, it is the most important. It is a red dwarf star, only 12% the mass of the Sun, nearly invisible without a telescope. Proxima Centauri is officially the closest known star to our solar system, slightly closer than Alpha Centauri A and B. Red dwarfs are the most common stars in the Milky Way. For years, scientists believed this made Proxima Centauri an unlikely place for life. Then came one of the most important discoveries in modern astronomy. In 2016, astronomers confirmed the existence of Proxima Centauri B, an exoplanet orbiting Proxima Centauri. This planet is at least 1.3 times the mass of Earth, is likely rocky, orbits within the habitable zone, completes one orbit every 11.2 Earth days. Because Proxima is dim, its habitable zone lies extremely close to the star. This raises major scientific questions. Is the planet tidally locked? Does it have a magnetic field? Can its atmosphere survive stellar flares? Some models suggest Proxima B could retain an atmosphere and even oceans, especially if it formed farther out and migrated inward. This makes Proxima be the closest serious candidate for extraterrestrial habitability ever discovered. Evidence suggests that Proxima Centauri may host additional planets. One candidate, Proxima Centauri C, appears to be larger than Earth, colder, orbiting much farther out. Astronomers have also detected possible dust disks and asteroid belts, indicating a complex planetary system. Meanwhile, Alpha Centauri A and B remain under intense observation. Detecting Earth-sized planets around them would be a historic breakthrough. At current spacecraft speeds, reaching Alpha Centauri would take over 70,000 years. But new ideas are changing that. One of the most ambitious is Breakthrough Starshot, a project proposing tiny spacecraft, powered by Earth-based lasers, accelerated to 20% the speed of light. At that speed, probes could reach Alpha Centauri in about 20 years. This would mark humanity's first interstellar mission. Alpha Centauri has been observed for. Could life exist there? To answer this scientifically, we must move beyond imagination and examine the actual conditions required for life as we understand it. Life on Earth depends on several key factors: liquid water, a stable energy source, an atmosphere, protection from harmful radiation, long-term environmental stability. Alpha Centauri offers some of these conditions, but not without complications. A habitable zone is often described as the region around a star where liquid water can exist on a planet's surface. But distance alone is not enough. In the Alpha Centauri system, Alpha Centauri A and B have wide, stable habitable zones. Proxima Centauri's habitable zone is extremely close to the star. This creates two very different habitability scenarios. If Earth-like planets exist around Alpha Centauri A or B, they would likely experience stable daylight cycles. Each technological leap radiation has brought Alpha Centauri long-term climate stability to science. Computer simulations show that Alpha Centauri could more than just nearby for billions of years in stable testing ground for planetary science. Even benchmark for habitability studies. From an astrobiology realistic target, these planets would be more promising if life exists anywhere. The problem is not theory. Alpha Centauri is one of the first places we are likely to find. Makes small planets extremely represents the boundary between imagination and Proxima B. It is close enough located in the habitable zone, close enough to reach, faces serious and close enough to matter. Likely for the first time in history, humanity can realistically plan high radiation to another star system. However, Alpha Centauri is not the end of possible solutions. It is the beginning. A thick atmosphere. If you found this documentary valuable, a strong magnetic field could deflect radiation and share it with subsurface oceans could protect life. Your support helps us continue exploring the universe. It would likely be very different from Earth life. Next time, but we go even deeper.